Hey math kids, today we're going to use the parallelogram properties that we talked about in the previous video with some problems. And so we are given a parallelogram. And let's see, we got A, D, C, B, and this point is E. Okay. So the first one says measurement of angle BAC is equal to 50 degrees. We want to find measurement of angle DCA. So we're going to mark this on this diagram. So BAC, BAC, this is 50 degrees, and we want to find DCA. So DCA is this one. Now this one, actually, if we draw from a previous theorem that we had a long time ago, we could think of this like parallel lines cut by a transversal, and this is 50, and then we want to know this, and so we know that that's equal to 50 degrees because they are alternate interior angles. So that's how I would do this one, and then just move on. Okay, now there's one diagram for each number on your homework, but we're not claiming that all those angles are true at the same time. So every time you do a problem, you're going to reimagine the diagram. So the diagram is like fresh every single time. Okay, now we're going to say measure of angle ADC is equal to 70 degrees. We want to find the measure of angle DAB. So we got ADC, so that's that entire angle, and that is 70 degrees. And then we have DAB. DAB, that's that entire angle. Now there's a property of parallelograms that says consecutive angles are supplementary. So if we just take 180 and subtract 70, we will get 110, and that is that angle measurement. Once again, we'll make the diagram fresh each time and kind of forget about what we did before. Measurement of angle DCB is equal to 140. Measurement of angle DCA is equal to 40. And then we want to find the measurement of angle BAC. So DCB, that's this one, that's 140. And then we have DCA, DCA. So that's just the lower portion, so it's just this is 40. And we want to know BAC. Okay, once again, it's just that parallel lines cut by a transversal, where this is 40, and what is this? Well, alternate interior angles are congruent, so it's 40, so we actually didn't even need this information. Okay. Once again, we get rid of all the stuff on the diagram. Alright, I can't step back enough to get rid of that, but that's okay. Now we're given that AE is equal to 14. No, let's not do that. Let's do 10. 10 centimeters. DE is 20 centimeters. Find EB. Okay, so AE from here to here is 10. DE is 20. And we want to find EB. Okay, so once again, we're given information that doesn't matter. This doesn't matter at all. Parallelograms have diagonals that bisect each other, so this one is also 20, so this is 20 centimeters. Alright, now we're going to change diagrams. This time it's given that this is a rhombus, and A, B, C, D, okay, so A, B, C, D, E, and once again it's a rhombus, so we want to think of the rhombus properties. Okay, so we have ADE is equal to 30, DAE is what we want to find. Oh, and also ABD. Okay, so ADE, so just this portion is 30, and then we want to find DAE, so we'll call that one X, and then ABD, Okay, so a couple things going on here. With this one, we're going to just pull out this triangle, and this is 30, this is 90, because in a rhombus, we create 90-degree angles with diagonals. And so 90, so this is 120, and the interior angles of a triangle need to add up to 180, so this one's going to be 60. Oh wait, why did I write 30? That actually is the answer, but this was supposed to be unknown, so why? So remember what happens also is that angles are bisected in a rhombus, and so this is also 30, and because opposite angles are congruent in any parallelogram, this will also be 30 and 30, and so the answer here is 30. Okay, want to get rid of everything on the diagram each time. I'll just cross these out like this. Actually, I can just do that. Okay. Now, the next one with this diagram, measurement of angle ABC is equal to 64 degrees. No, let's not do that. Let's do 60. And then find the measure of angle ABE. Okay, so ABC, so this big angle is 60. And then ABE, so just this little, let's change the color. So just from here to here, we want to know. Well, the theorem is that diagonals bisect the angles in rhombi, and so this will just be half of that, and so it'll be 30 degrees. Okay, clear the diagram each time. And then we say AE is equal to 5 centimeters. DE is equal to 6 centimeters. And we want to find DB as well as AD. Okay, so AE from here to here is 5. DE is 6. And we want to find DB. Okay, so diagonals in any parallelogram bisect each other. So we know that this is 6 and this is 6, and so if we find the entire thing, that's going to be 12 centimeters. And then we also want to find AD. So we just think of this, we know it's a right triangle because in a rhombus, the diagonals are perpendicular to each other. And so we can use Pythagorean Theorem with this. So we can say 5 squared plus 6 squared equals AD squared. So we get 25 plus 36, and I'm just going to change that to an x. And so if I add these, 50, 61 equals x squared, and then just square root both sides, and I'm not even going to worry about that. If you want to plug it into a calculator, go for it, but it's just square root of 61 centimeters. Okay? Alright, clear the diagram. Okay, can't quite clear the diagram. Won't let me go back far enough, but I can get rid of those. And the last one with this diagram, AD equals 10 centimeters, BD equals 20 centimeters, find AC. Okay, so AC, or wait, AD, let's see, we'll do this. Okay, so AD right there is 10, BD, this entire thing, is 20, and then find AC. So basically how we're going to approach it, this entire thing's 20, so this is going to be 10 and 10. And that's not going to work. Alright, I got to modify this problem just a little bit. I'm going to change this to an 11. Okay. Because if this is 10 and this is the hypotenuse, that doesn't make sense. So that's why I did that. Okay, so it should have been given as 11 and 20. And then this would be 10 and 10 because diagonals bisect each other. Okay, diagonals bisect each other, so we know the 20 splits evenly as 10 and 10. And we're trying to find AC. But what we're first going to do is just find x on this triangle. So we can use the Pythagorean Theorem again. This is going to be our C. This can be our A, and this can be our B. So we're going to say 10 squared plus x squared equals 11 squared. And then figure out what that is. Subtract 100 over here, so x squared equals 21. Square root both sides. X equals the square root of 21. But then we have to double that because diagonals bisect each other. So just this portion, let's change color, just this portion is the square root of 21. So we need another square root of 21. So I'm just going to say 2 square root of 21. Once again, you can plug it into a calculator and figure out the exact value, or in a decimal approximation that will help you understand a little bit better. But if you leave it like that, I'm okay with that. Okay. All right. Now we have a new diagram. This time we have a rectangle. And we're given diagonals like that. A, B, C, D, E, and it says the measurement of BAC is 30, the measurement of ACB, and the measurement of DAC. So we want to find both of those. So BAC is going to be 30. And we want to find ACB. ACB. Okay. What we're going to do for this one, parallel lines cut by a transversal again. So this is 30. So that means that this is 30. But what we actually want is this one. Or not exactly that one. Okay, anyway. This is 30 on the diagram. Now, we know that this is a 90-degree angle because it's a rectangle. And so this has to be 60. So those add up to 90. Okay, now we want to find DAC. DAC. That's actually the same thing. That's a 90-degree angle, so that has to be 60. All right, clear the diagram. Get rid of these. Okay, the next one says measurement of angle AEB is equal to 120. Find the measurement of angle CAB. Okay, so AEB, this is 120. And then CAB, Okay, what's going on here is because we know that the diagonals in a rectangle are congruent and they bisect each other, we know that this is congruent to this. And because of that, we know this is an isosceles triangle, and so we know that this angle is congruent to this angle. So, since all of these have to add up in this triangle, they have to add up to 180 degrees. If we take 120, or 180 minus 120, we get 60 degrees, and that has to be split evenly between these two base angles. And so that's how we know that it's 30 degrees. Okay. diagram. Okay. Now we have DE is equal to 9. We want to find AC. Okay, so DE is 9. AC is this entire diagonal. Okay, so in parallelogram, the bell's ringing. Okay, so in a parallelogram, the diagonals are congruent, or sorry, in a rectangle, the diagonals are congruent, and in all parallelograms, the diagonals bisect each other. So we know this is also 9. So we know the total length of DB is 18, but we also know that DB is equal to AC, and so that's going to be 18 as well. Those are centimeters, by the way. All right, and we have one more to do with this. Okay, we have AD is equal to 10 centimeters. DC is equal to 12 centimeters. We want to find AE. Okay, so this one is 10. This one is 12. We want to find AE. Alright, so first what we're going to do is we're going to find AC. This is a right angle because it's a rectangle, and so we can do Pythagorean Theorem, and we're going to find the entire length of that, so I'll just call it x. So 100 plus 144, that's 244, and then we square root both sides, so x equals the square root of 244. Once again, you can turn that into a decimal if you want to, but that represents this entire thing. Now, in a parallelogram, and which a rectangle is a parallelogram, the diagonals bisect each other, and so if we just cut this in half, we will end up with AE. And so even though this looks messy and is definitely not simplified, I'm just going to write it like that over 2. Once again, feel free to plug this into a calculator, get a decimal, and then divide that decimal by 2 if it works better for you that way. If you need additional help, please come to Math Lab. Until then, calculate.